In our previous video, we took a look at what the derivative is and what it's measuring, that slope of the tangent line. Now we're ready to actually calculate derivatives. And to do that, we use that definition that the limit as h goes to 0 of f of x plus h minus f of x all over h finds that derivative value. So for example, if I have f of x equals x squared minus 5x plus 1, we can start working to find that derivative. One thing that I find is helpful is first figure out what f of x plus h is. So I'm going to do f of x plus h, which replaces each of the x's with an x plus h, giving me x plus h squared minus 5 times x plus h plus 1. And let's go ahead and simplify that by squaring, which is going to give us x squared plus 2xh plus h squared. Don't forget the middle term, which comes from multiplying them together and then doubling it. Distribute the 5. It gives us negative 5x minus 5h plus 1. Then if I go to the definition of the derivative of the function is equal to the limit as h goes to 0 of the f of x plus h, which is x squared plus 2xh plus h squared minus 5x minus 5h plus 1. Subtract the original function, which is x squared minus 5x plus 1, all over h. And notice I took the time to put that original function in parentheses because that negative sign is going to have to distribute through to everything. So let's do that. When I distribute the negative, I'm going to get a negative x, a positive 5, and a negative 1. So distributing that negative through. And then to simplify, I see we've got an x squared minus x squared, which is 0. I see we've got a negative 5x plus 5x, which is 0. I see we've got a positive 1 and a minus 1, which is 0. So now I have the limit as h goes to 0 of 2xh plus h squared minus 5h all over h. In order to simplify this, our goal is going to be to remove that h from the denominator. We're removing the discontinuity because we can't plug 0 in right now. To do that, I can factor out an h from each of the terms in the numerator. So I get the limit as h goes to 0 of h times 2x plus h minus 5 all over h. And now those h's can reduce out. And once those h's reduce out, I can replace the h with the 0 that it's approaching, giving me 2x plus 0 minus 5, or just 2x minus 5 is the derivative of this function. This expression, 2x minus 5, tells me how fast x squared minus 5x plus 1 is changing at any given point. Let's try and do this again with a second example. Let's try f of x equals 2 over x. In that case, the f of x plus h is going to be 2 over the x plus h. So when I plug it into my limit formula for the derivative, it is equal to the limit as h goes to 0 of the f of x plus h, which is 2 over x plus h, minus the f of x, which is 2 over x, all over h. Now this one we can't just factor an h out like we did last time, but we can get rid of the compound fraction by multiplying each term on top and bottom by the denominators of x and x plus h. When I do that, the x's reduce out of the last term, the x plus h's reduce out of the last term, so we get the limit as h goes to 0 of 2x minus 2 times x plus h all over hx times x plus h. I like that the denominator is factored. We're going to leave it like that, but I am going to distribute the negative 2 through, giving me the limit as h goes to 0 of 2x minus 2x minus 2h all over hx times x plus h. Then if I look at simplifying, we've got a 2x minus 2x, which is 0. And now my numerator actually only has one term in it, negative 2h. So I can reduce out the h. And that's going to leave me the limit as h goes to 0 of negative 2 over x times x plus h. Well, let's go ahead and replace the h with 0 since we removed that discontinuity. That's going to give us negative 2 over x times x plus 0. Well, x plus 0 is just x, so we end up with negative 2 over x times x, which is x squared. And so the rate of change of this function, 2 over x, is negative 2 over x squared. Once we've calculated these derivatives, this is the slope of the tangent line. The next step in our next video will be to find the equation of that tangent line.